Sample problem 11-03. Three forces of the same magnitude are applied to a rectangle as shown. Forces F1 and F2 act at 45 degrees to the angle, to the vertical. For each force, indicate whether the torque around an axis of this given point would be clockwise, anti-clockwise, or zero. So for all of these, we're really going to be coming back to that in general, the torque is R perpendicular F, where R perpendicular is the perpendicular distance to the line of action. What is the line of action? The line of action is the line containing the force. So I'm going to just label our three forces here. F1 has this as its line of action, and F2 has this as its line of action, and then F3 has this as its line of action. Notice in each case it really is just the line in which that arrow lives. So now we can just look for each of these and say around, for instance, point A, and I didn't draw the green one very well, so I'm going to go back and fix it right now. Doesn't change anything, it was just bad drawing on my part. Because we know that at 45 degrees, it's going to hit each corner. So it's going to look at that. And that's going to be crucial in a second. So if we look at case A, when it's rotating around that point, well, we can say that the green line passes through that point, so the shortest distance between the line and the point would be 0. So that's interesting. And then we can say that for the blue one, the shortest distance is going to lie along this segment. And so it's not going to be 0. We don't really need to know the length then. All we really need to know is which way does it tend to do it. So if I pull on this corner with this thing held constant, it's going to yank the thing in that direction. So we're going to end up with a clockwise rotation. On the other hand, looking at the purple guy, if I were to pull this point, it's going to try and tilt the thing that way. So that's going to be anti-clockwise. Anti-clockwise is the physicist's way of saying counterclockwise for whatever reason. We're a big fan of anti meaning opposite, so we often say that. It also means that it's A and C rather than C and CW. Not a big deal. The same kind of reasoning if we look now at around point B. The purple guy goes through point P, so B, so there's 0 torque. And the blue guy is still pulling that direction. Tends to pull the same way. It's not as strong, but tends to pull it the same way. And then we can look at the green guy, and the green guy is pushing it, right? So if we push to the side, it's going to try and spin it. It's going to spin it this way, which is anti-clockwise. And then for the final one, if we look at point C, we get some interesting things going on here. We get that the blue line goes through point C, so there's no torque. And the green line goes through point C, so there's no torque. And the purple line goes through point C, so there's no torque. So that's how that ends up.